All right. Good morning, everyone. Welcome to today's session. To everyone joining on YouTube, joining on Zoom, and even physically. At least seeing a couple of people, one person that I'm sure of now coming today. So I'm glad to have everyone. Welcome to today's session. We are having I think it's really been an amazing program over the last um, I think that's 6 weeks now. Yes. So today is the 12th and the last session, and we're really glad and excited to have everyone who has followed through right from beginning up until now, people that joined along the way. You are all welcome, and it's really exciting to have joined with you this last how many days now? It's been quite a number of days. It's really exciting. It's really exciting. Glad that we've all learned. I'm glad that every single person that's been a part of this program has. I'm sure we can say that we've learned. I mean, from when we started up until now, we've learned quite a lot. So big kudos to everyone. As always, we'll start off exactly 10:05. So we have the next 3 minutes to dial in, get our friends to dial in and join, and also sign in our attendance. Really important. Okay, and today's really exciting because today we're going to take a look at the Kaggle competition, which will be launched today, which will start today. All the instructions and everything you need to be provided. Okay, great. So let's sign in and let's get started. Are we excited? Just drop some emoji. How do I scan the attendance? Okay, yeah, it's really simple. It's how we've always been doing it. It's either you type in this link to your browser or you take your phone, you use a QR code scanner and you scan the QR code that is displayed. Lukman, I see you. Lukman Ali. Joshua, I see you. I see you. Oluwasha. All right. Excited to be here. Yes. Awesome. Great. All right. All right. So let's get started. Good morning, everyone. I am excited to be here with us today, like I said earlier, to close the session with us today. It's been an exciting last, how many weeks now? 6. And we've all, come so far. We've learned a lot. I've seen the way our code snippets that we share on the group, they've evolved, right? From our usual errors. Now people are trying exciting things, people are trying more advanced things, and that's really amazing. And that's really the goal for us. And we're excited to see everyone making progress. So today we've covered quite a number of things in the last few sessions. So today we are going to talk about introduction to regression. Basically, today's class is an introduction to linear regression. Okay, so that's what we're going to be doing. And then we'll also take a look at the Kaggle competition. Then we'll also look at how guides to the Kaggle competition, how to go about it, how to do it, and also support materials that are available for you. And largely all the support material really is in the AI integration that's the content for the AI integration. You find the videos and all the things that you need there. All right. Okay. So we'll have a general overview, just to understand how the regression algorithm works. List types of regression algorithms. We'll build a linear regression algorithm to sklearn, a scikit-learn, and then we'll evaluate our regression model's performance. Okay, I think we're good to do it. All right. So a quick recap. Machine learning models and algorithms allow computers to automate tasks that would otherwise take manual efforts, time, as well as resources. It learns to interpret data and provide insights to data. And the idea is that the machine learning performance improves with experience. Now, what's so special about linear regression? Linear regression, not just linear, let's just say regression, because that's what we're looking at the general regression now. It's a set of processes that can be used to estimate the relationship between variables. I will call our attention to our linear regression, which most of us must be familiar with from school. That is y equals mx plus c, equation of a straight line. And now that we can extrapolate that to begin to look at areas not covered by our data, and then say that if y is this, what is x? If x is this, what is c? And all those things. All right. So examples of tasks that can be solved using regression. Before a data set can be trained on a regression model, the label must be a continuous variable, not discrete. What does that mean? The label must be a range of values that can go from one end to another, and the difference between each or successive values or any values is not constant. They can differ by any amount. For example, the salaries or years of experience, right? It could be 2, it could be 5, it could be 8, it could be any number. It's not like something that is that binary, or you know exactly how many values they will be. So if we know exactly how many values the variables or the output will be, we say that that is discrete. But if we do not, we say that that is continuous. All right. So determining things like determining cost level from the age of patients, predicting salary from years of experience, predicting students' grade based on total study time, predicting examination score based on students' test score, etc. So basically, it's just to see how we can take a wide range of data that we have, wide range of data that is available to us, look at the predictor of the target variables that are continuous, right? Not discrete now, and then be able to predict the amount, right, for unknown. Okay, so let's look at this question. The regression algorithm we'll be looking at, we'll just take an example of Mama T restaurant's data set. And the objective is to predict the amount of tip gratuity in Naira given to a food server based on the total bill, gender, if the person is a smoker, whether they smoke or not, the day of the week, time, and size of the party or the dinner or whatever. So the label for this problem is tip. All right. Features, there are 6 features, and they include the total bill, how much the person spent, the gender, male or female, smoker, are they smoking or not, the day, the time, and the size of the size of the party in the restaurant that day. All right. So let's take a look at what we have. Now, we plan to use the following regression models to predict the amount of tip that will be given in that restaurant that day. Ordinary least square, support vector machine, extreme gradient boosting, decision tree, and random forest. Now, it's really important to note this because all these algorithms will be using, I mean, this is still regression, but the task we might be given in the hackathon might not be a regression task, it might be a classification task, it might be maybe unsupervised, right? So it's important to understand the kind of task that we have. So for example, here we have established that our task is a regression task. We're trying to predict an amount of tip. Yes, the data set will be different because this is a different question, but the data set will be available to you right after the class. Okay. So right now, what we have to do is we can follow, and well, I think what I'll just do is for people that really want to follow, I'm going to pause the class for a bit, and then I will put the data set on the info pack right away so you can all practice as we go. Okay? All right, so let's hold on a bit. I'm going to drop the data set on the info pack right now. Okay. So I will just stop here for a bit. Okay, just give me a minute. Okay, so right about now, you can check the info pack and you will find, so you should be able to find the data set on the info pack right away. So like we did, I'm sure we all know how to import our data sets, right? So please check the info pack for the data set and you can follow right along. All right, so we have our data set on the info pack now, like I mentioned. So please, you just go there, you'll find the data right away. Okay, let's go. So let's import our modules. We import the modules we'll be using for this task. Number one, NumPy, that's import NumPy as NP. Pandas, import pandas as PD. Import matplotlib.pyplot as PLT. Import Seaborn as SNS. Import pandas profiling. So from pandas profiling, import profile report. So if you do not have pandas profiling already installed, you have to install it, and you need the internet to do that. So all you have to do is, I believe it's that pip install pandas space. Let me check. Okay, I think there is an, yes, no, there's an iframe. Pandas profile. Yes, so this, I believe it's not giving an error. So all you have to do is connect to the internet. You have the data set, you don't see it. Yeah, just check where the past session recordings, where you find the recordings, where the other data sets have been. Yeah, just reload the data set. It's there already. So pip install pandas profiling. I will install the pandas profile for you. All right. Okay, so let's import our data set. Okay. All right, so tip is, so we are going to import our data set. If it's in the same folder where you have the, okay, so this is done. Great. So if it's in the same folder where you have the, just drop, I will always recommend, just drop the data set in the same, exact same folder where your notebook.ipynb file is. So all you have to do is, in that case, drop, all you have to do is this, right? So you just tips.csv, right? Read, all that's all you have to do. Okay, so we import that and we check out the first 10. Oh, look at me. Let me run this. Okay, so all right, so importing all our libraries, packages, and everything we need. Once that is done importing, the next thing is so this is just the output from installing pandas profiling. Okay. This is still importing. Okay, done. That again. Have to install this now. Okay, now is anybody else having this error after they installed it so that we can? No. So I will. So what I will just do is I'll walk around this, right? Since we already have the output. So let's go. Import your zip data set using pd.read.csv and using .head method of the data frame. Now we are able to check out the first 10 rows of our data set. So this is the total bill, this is the tip amount, right? This is what I predicted. Remember? Yeah, but I actually installed it. I That's what I did here. This is installing pandas provider. Don't worry, I know how to solve that. Just okay, so gender, smoker, yes, no, the day, no time, time by the earth, and the size. Okay, so let's check out the shape of the and in the data set. Remember, we imported the whole data set as so 744 rows, there are 7 columns. All right. So by the time you run pandas profiling to get the report, you will get an HTML file. Now because I don't the installation here isn't working out. So yeah, I know, right? Let me try that. So I'll just restart my kernel. But if you do have it installed, just go ahead and tip the profile report and to generate a kind of analysis on your data set explaining certain parts of the data set. So how many of us can do that or we have done that? Just indicate on the chart. Let's see how many people are able to get that. Just indicate on my profile report, done. Didn't get it. Someone said she didn't get it. So this is tip.profile_report. Right. But don't worry, if you didn't get it, it's fine. It's just for our EDA. We'll be able to still work without it. All right, so we need to do some visualizations just to see exactly what our data set looks like, right? Because it's all just numbers. How do we understand so we know how to proceed with this problem? Remember, we imported C1 as SMS, so we call the box plot. We will just do a short little box plot to just see how the amount of variation of that's about an error rate in our gender, right? So X is gender, Y is tip. How the gender relates to the tip. Okay, do we get that? How gender relates to tip? So data set tip. I'm saying all this so we can have time for those who follow, they can actually type it out. PLT, remember we imported matplotlib or pyplot as PLT. So that's the whole thing we are calling now. But Y label is going to be what amount of tip. That is this amount of tip, male, female. Alright. When you run this, you should get we say tip is not defined. Why is tip not defined? Run this again. We started it. See that? We started it. All right, so let's go. So you should get that box plot that looks like this, right? And this looks good. This looks good. Okay. Now let's look at the count as well. How many or how much is it varying? Let's see the amount of tips given by both gender. Okay. Just want to see how they vary with gender to see if it's tilted to one side. Maybe all one gender is giving, oh, this is not okay. So this is showing now all, it's not showing all gender, it's showing all the things because it's a continuous variable, right? I wish, so if it was, what's it called now? A discrete variable will have those discrete columns there. So let's make our seen what we need to balance with our box plot. Also, we check for the tip, and so basically what we are checking is for each of the predictor variables, we are checking how is it varying against our label? How is the fact that if the person smoke, how does it vary against the tip I want to give it? And we see that the variations they are not too much, right? They're not too much. Smoker and non-smokers all give almost the same amount of tip, so it doesn't really matter. What about the time? Let's check on the time. Versus time, right? Same thing. The time lunch and dinner didn't really matter. So we move straight to building our models. This is just a very simple problem, very simple. Just showing simply here that okay, checking this against this, checking that against that. Right. So we want to check our metrics now. So we need to know because when we build our model, we must evaluate our model. Right? So from sklearn import metrics, this will be for our model evaluation. That's how we know that our model is actually performing well or not. Is it doing what I want it to or not? Or am I just train a model and I am hoping that it does what I need it to do? All right, so from sklearn model underscore selection, import train test split. Note the underscores, the dots, really important. So what's train test split? Train test split is going to divide our data into training and test set. I know we've covered this before in previous sessions that your data set is split into what? The train set and the test set. We're going to train on the train set and then we will test and look at evaluate our model on the test set. Okay. So data processing, the idea of processing is to separate features and the label from the data. So we have our data features, we have the labels, but we want to separate them. We want to, because we cannot, we will not train with the labels in the data set. And what do we mean? Remember when we said tip, let's run this. So tip.head gives us all this, right? And our train set will also contain this. The idea of the train set is to let the model know if this is this, this should be this, if that is that, that should be that. But when we actually train, we cannot have the labels in the data set. Otherwise, it will be like we've given the computer the answer. We're not asking it the question again. So we need to remove the labels. And how do we do that? We use the pandas drop method. All we have to do is indicate what do we want to drop. We want to drop tip. Okay, and what axis column. We'll drop the variable tip, right? And then but we also want y to be equal to tip. I'm using lowercase y here and uppercase x. So we want y to also be equal to tip. Y is our labels, right? Remember the y is the label. So can we view the modeling? Yeah, you can go over the video any other time. So tip the drop, we're going to drop tip, and then let's that we'll assign that to x. So every other thing in this data set except tip enters x, and only tip, which is our labels, goes into y. So that means the variables go into x and the labels go into y. So if I run this, done that already, by the time we now say x.head, you will see that tip is gone from the data set. And y.head will give us just the labels, the tips. Now, the label is continuous, it's a regression task. What do we do? Call it one-hot encoding. And the idea is we create a one-hot encoding for all the categorical features in the data set, because some algorithms cannot work directly with categorical data. Some can, most can't. So they require all the input variables to be numeric. So that means we need to convert all these male, female, yes, no, Thursday, Sunday, lunch, dinner, into numeric values so that the model can actually work on them. If we do not do that and just go ahead and try to do the model, we will get errors. We tell you that type error or some other kind of errors. So we can actually easily do this. There are ways we can do manually, use maybe use a dictionary, and then for this, this comprehension, get everything to numbers that way. But pandas makes it super easy. There's a method called get dummies, and get dummies pandas method is able to create one-hot encoding for any categorical feature, and that's what we're going to do. By the time we do pd.getDummies, what do you want to get dummies for? X. That contains our variables. X, our predictor variables. So let's go ahead. pd.getDummies X. By the time we call that, you see that gender female has become 0, 1, without 0 and 1, and male. Now, here's the thing. Let's look at it together. When gender female is 0, that means it has to be male. So we see 1 there. If it's female, it cannot be male. 0. So that's the idea of one encoding. So smoker no becomes 1, yes becomes 0. And we'll see the same thing goes on for all the days. So you see that it's created a lot of columns, right? So Friday, so it has to be just one of them. So for all the other categories, there will be 0, while the category that is true or that is that has a value in that row, in that data point, is going to take the value of 1. It's like that's basically what one-hot encoding is. It makes everything 1 or 0 for the categories, and the category that is actually for that row becomes 1, and if not, all the other categories become 0. It's a simple way of just converting our categorical variables into numerical variables. So that's what one-hot encoding does, and that's what we have done there. All right. So we'll now save this result of the one-hot encoding into X. No, these are one-hot encoding, right? But we now need to save it. So we save it into X. We assign it into the variable X. This is why we have to, variable assignment. We cover that. So that's simple. Now, when we do X.head, what do we get? We get our one-hot encoded data set. By getting warmer, we're getting there. Let's see the shape now. Now we still have 744 rows and 15 columns. We started from how many columns? We started from 1, 2, 3, 4, 5, 6, 7 columns. Let me see where we did the shape. Let's just, yeah, 7 columns. Started from 7 columns, and now we had 15 columns. Imagine if we had, now here's the funny part. If we had the data set had maybe 20 categories, if you use one auto encoding, that means you are going to have additional 20 columns. So it really expands the data set, and which would be for good or for bad, but mostly works quite good. Next thing we need to do is to split it into training and the test set. Now, this is really important because we're using train test which we've imported, right? But what is important here is to remember that why are we splitting our data into training and test? We are splitting into training and test set because we need to evaluate our model. We will evaluate on the test set, or we will predict on the test set, and then we will train on the train set, which will not have the labels, so that we are able to test. So we'll give the computer the questions, and then we now check if it's able to get the answers correct. Remember, we've removed the labels from X. So X doesn't contain the labels, only Y contains the labels. So we want 4 things. We want X train, X test. We want Y train and Y test, because we must train X, give X some Y to train on. X test must also have some Y test to test on. So basically, X goes into train and test, Y also goes into train and test. Okay. So we're splitting our data set, which enables the train and test data, using the train test split function from scikit-learn. The training set will be 80%, while the test set will be 20%. We use the random state of 1, 2, 3, 4, so that we can all get the same set of data. Random state helps to just shuffle the data or select the data such that you can always arrive at the same data set that the model will select, or that the train test will select. So if we use random state 5, use another random state, we will get different answers. We'll get different answers. But if we all use the same random state, it will train on the same selection of data points for each of us. So that's the idea of random state there. Okay, so generally, yeah. So he's asking if we use different random states, how we do it, and we get different answers with every variation. In a proper data set, there shouldn't be so much of a variation. There shouldn't even be that much variation. It should not. But you find that in some data sets, because the data set could be, depending on the distribution, really, and so many other things. The data set could be, maybe it could make sense at some point, and then sometime below it might not make sense. But the way to shuffle it really is to try to maybe randomize and make everything a bit in the shufflings. The result should be, we expect that it should be, uniform, it should be the same, but it's not going to be so uniform. So you might see 0.2, 0.3, 5, 6, plus or minus differences in our results. So train test split X train, X test, Y train, Y test. And we run this, okay, and getting the name error Y. It says train test split is not defined. That means I did not run my imports here. Let me run that again. Yeah, so that's importing now. So, all right, that's imported. Good, we're good to go. We now have the pair of training data: X train, Y train, test data, X test, Y test. And it might all seem a bit confusing now: X test, Y test, and X train, Y train. But trust me, when you've done this over and over again, it makes sense to you. You know what we are doing, you know why we are doing it, and you're able to do it and even do other things, because it's not only train test which you can use. What's the other one? I don't remember now. But basically I just want to be clear that there are various numerous ways. There are about three common ways that split our data set. But the most common really is train test by this my I don't remember. It's scikit-learn. So we have our pair of training data: X train, Y train, and X test, Y test. Next up is training our model, which is really simple. Now, this model is a small model. The data set itself is a small data set, so we are not going to have much of a problem. And from scikit-learn, we import what? Linear models, we import linear regression. Now you recall, let me point out here that we shared text content on the info pack. If you go to the info pack, you will actually see a mathematical breakdown of the algorithm behind linear regression. It's there in the info pack. When you check the resources, the AI Vision text material, you'll find there the mathematical breakdown, what is working behind this linear regression algorithm. And but simply, in simplest term, it is simply y equals to mx plus c. That's the equation, basic equation running behind. Of course, there are other algorithms, but that's basically the equation of a straight line, like I mentioned here, is regression. I believe this is um, something we are quite familiar with. So from sklearn, the model import linear regression. We import that. Then we create an object of class linear regression to train the model on. And when we say train a model, what we actually mean is this. There is a model body already existing, like linear regression, XGBoost, support vector machine, k-means clustering, KNN, k-nearest neighbor, other ones, cat boost, random forest. There are all these algorithms already existing. Random forest regressor, random forest classifier, they exist. So we take these models, the assumption the models make, and then we fit our data set on this model. That is, we take these models and then we train them on our data set. We let the model work for our data set. We let the model learn the patterns in our data set. Why do we do this? Because each model is unique in itself and it has some kind of patterns that each of them are better suited to learn. So for a task, support vector machine might be fine. But when you run a random forest on it, random forest might perform better. Linear regression might be okay, but when you run another model on it, it might perform better. So that's why, because when you get to the hackathon, you want to improve your results, try different models. All right. So we want to fit our data set. We want to fit our data set on these models now. So linear model is the linear regression. So we assign that object linear regression. Please note the capital letters because this is an inbuilt class. So if you type something else, it's going to give you an error later on. It's going to give you an error. So this one is just a variable we are, the left side is just a variable we are selecting. So linear model does fit. This is where the training actually happens, right? Linear model does fit X train, Y train. So we are fitting our data set inside the linear regression model or on the linear regression model more accurately. So I believe I have run this, yes. Good. It's done. Just like that, it is fitted and it has trained. I know, right? So simple. Isn't it simple? Please, in the chat, let me know. Isn't it simple to train our model? Very simple. However, you might find out that when you are training a larger data set or maybe people using their mobile phones, yeah, someone says mixing. I have a feeling some of us, these teachers, person has some experience there, some who is coming. But really, it's actually this easy. It's the same. It's simple for you. It's the same process. What I'm trying to establish is the principle behind it. If you don't understand the principle, whatever the problem, you're able to apply it to it. Right? So it might not be the same problem, but we understand the principle is I've processed my data. I have gotten what now? Everything I need to. Sometimes we have to remove non-values, like missing values. And to do that, just really simple pd dot .fona or some other methods that are actually really interesting. And other things that we can do. Oh, instead of statistics, I see. Okay, that's not them. All this you must really be having fun. Statistics people will really have fun in this class. All right, so linear model dot fit. We've done that. Okay. All right. So once we fitted, next thing to do is to do our prediction. So whenever we call linear model, we are calling a. So now remember we've called this class into linear model and we've trained it on our data set. What has happened? Whenever I call linear model, I am calling a model that has learned the pattern in this data set. And any other data point, any new data that comes from the same place, we want to assume it's the same place, or that relates to this data set, I can now predict what the label will be with this data, this model that I have fitted on. I'll say that again. Once I've fitted this linear regression model on my data set, train and X train and Y train, whenever I get a new data point, I only need to call this fitted model, linear model, and then predict it on the test or whatever the new data set is. And I can now get the labels. Why? Because it has learned by being fit on the data set, the model, the linear regression model has learned patterns in this data set. And once any new data point comes, it can extrapolate, it can predict, it can know what the value, the label should be, which is what we want to predict, which in this case is the amount of tip that will be given. All right, so let's take a look. Linear model dot predict X test. By the time we run this, you're going to get all this, and these are the predicted tips. These are the predicted tips for the values in X test. Now, X test contains something like this as well, right? Contains something like this. So remember, we split our data into test and train so we can evaluate. Now, let's see how accurate is our model. Let's save it first. Save this model, linear model. So it's now linear model prediction. We saved our predictions into this variable, evaluating our model. Now, we evaluate because it's a linear regression with the root mean square error. Statistics people, I'm sure they already get that. But basically, the root mean square error is just the predicted label minus actual over n squared and sum to n, find the root. Idris is really having a wonderful time. All right, so basically, so let's evaluate. So the idea is how far away from the actual values were our predictions. That's what we want to get now. That's the idea of the square error. How far, you can see this line is the line, but this could be maybe our predictions, and this is how far away from what it should be that we got. Right? I mean, this is our model, right? This could be the actual data points. Let's take a look. So we'll use the so y test now, y test minus linear model prediction. To get this. So since the prediction is continuous, we can only measure how far the prediction is from the actual values. Do you get it? For something like classification, it's easier. It's either yes or no, it's either this class or this class. But because it's continuous, it's a number. We cannot measure. And how do we measure that? If somebody we tipped 400, but we predicted he would tip 450, how do we measure that? How accurate we are? All we need to do is find the difference between the actual values and what was predicted. So y test minus linear model prediction, because this is about an array, we can subtract two arrays. They are the same shape, so each value will just minus the other value and we get what we need to get. So we've done that. That's what we just did up here. And then positive ones show that the prediction, instead we have some positive, some negative, and the positive values simply show that the prediction is higher than the actual values, right? All the negative show that the prediction is below the actual values. Look at how much difference. This one, the actual value here, look at the difference. I mean, look at the difference. This one is almost, 29. It's not that much. 113, 159, that's a lot. That's a lot. MSC becomes metrics dot mean squared error, y test linear model prediction. And so what's the mean square error? 2's root, that's, then we take the root, right? That mean square error, and we obtain this. All right, so I'm going to run this again just so we can see the results and see. All right. Then we find the square root. Remember, we said that Python does not have its own square root function. We've imported numpy, but now we use numpy.sqrt square root of ms to find the root, and we obtain this. Therefore, the root mean square error for linear regression is 142. Okay. So let's take a short breather. Are we hope we are following? Let me go to the chat, see if any questions. Someone said it's simple since there was no data cleaning. Exactly, it's a very simple data set. So it's that there's not much data cleaning that was needed there. All right. I'm trying to see, go through our comments. Okay. Let's see. Someone's battery is down. Sorry. Okay. All right, let's go. I think that's okay, so let's try the random forest model. Let's note our RMSE. For linear regression, it was 142. So random forest, because we remember we pre-processed our data as we want to, so we don't need to pre-process again. All we need to do is fit. So sklearn.ensemble. So random forest is an ensemble algorithm. So sklearn.ensemble imports random forest regression. The cases of the words are really important when you're importing. So you're not calling variables, you're calling predefined things. So you need to make sure that you get. Yes, so I was going to wait for us to finish so we can interpret it. Basically, the RMSC, I think it's the higher, uh, for RMSC, the higher the value, the better or more accurate the model is. I'll confirm that before, by the end when we look through all the RMSCs together. So that we'll see that at the end. Okay. So we interpret everything together at the end. All right, so random forest regressor, let's check that out. So by the time we train on a random forest regressor, now there are hyperparameters that we can add and we can expand on to, tweak our models. But if, for example, these are the, once you don't put anything within the brackets, it's assumed the default value for all the hyperparameters. Look at all these guys. All these values can be tweaked. They can be, what's the word now? Adjusted to better tune the model for better accuracy. So let's check out the prediction. What do we have? For random forest, we have 157. That is higher than 142 from the linear regression. Let's try extreme gradient boosting now. As a matter of fact, this is regression. So if you are doing classification, so it will not be a regression to be a classifier, usually just classifier. So from XGBoost import XGB regressor, XGBoost model is equal to XGB regressor, use label encoder false. So set up all this. I want to believe, I think we have XGBoost installed. No, we don't. So let's install XGBoost. And I really hope I don't have to go through. Oh, and so it will take hours. Always remember you have to be connected to the internet for this to work. Okay, all right. Wow. So let's just move on since the results are there. So once you fit your model, import your model and you fit it, the next thing to do is just call the model and make your prediction. So we predict and then get our MSC and then same way we find the square root. This is higher for these tables. Right? Let's try support vector machine. The support vector machine. So we imported our X. So X has finished installing, and now we are importing. So X equals to an anaconda, that's why we have to install it. So this is the chance that we can. So X equals is not in anaconda. That's why we have to install this. So we've imported it now, and we've been able to fit our model and go on and do that. Doesn't change, right? So it's just this is 171, that's higher. All right, support vector machine. Now, support vector machine is in your scikit-learn, so we don't need to import and we don't need to install it again. So support vector regressor, SVM model is SVR. So SVM model does fit extreme, same thing, right? And you can see the hyperparameter. So another tip in the hackathon, you want to improve your model, switch on the hyperparameters. What we are doing really is showing you how to do it. Go online, right? And we'll give you links to resources. I'll give you links to all the resources you need, all the resources you need. Give you links to them. But expect you to go online and find out how can I make this better. And number one is see all these beautiful looking numbers, and we can use things like randomized search, grid search to find the best parameters that produce the best results. Right? We can combine models. We can combine the results of all these models, all three models, to see if it will give us a better result. We can, there are assembling methods, there are bagging methods, boosting methods, stacking methods that we can use. There are voting classifiers, and all. Basically, there are other, for example, for something like regression. Most times, I think for regression, things like bagging and boosting work better because it's continuous. So if you use like 3 and you average the prediction of the 3, it's usually most times closer to the actual. Because it's 3 models trying to prediction where one falls short, the other one might do better. So that's just kind of idea I want to look at. But it's not, there's no one rule. That's the beautiful thing. There's no one rule because the data sets are different. The circumstances are different. So you have to try, basically it's trial and error. Or EDA will give you some insight into what might work, what cannot work, or the best directions to go. All right, so SVM model, dates. Let's see what's the MSC. Oh, this is the big 140. So let's try the decision tree. Decision tree regressor, same thing, train, get all these values. Okay. All right. 224. Wow. Let me copy this and update this. That's 200. Nice. So model summary. Linear regression gave us 142, random model 160, gradient boost 171. Support vector machine can't train and test data without Python program. Okay, you can use. Okay, so let me get the question right. So we can use other languages R to write JavaScript, C, Java. Those are the ones I'm sure Go. Or basically, you can do machine learning now in almost any language really, right? But we are using Python because Python is really, you can try it in other languages and see how far you have to go, how easy it is. Python is easy, intuitive. Python has a lot of libraries that you need. And now, is Python the most excellent might not be. I mean, Python is a bit slow compared to maybe even R or C. But the point is, Python is really simple and intuitive. It has a lot of resources that you can use and learn from while you try to build your model. I think I gave an example in first class when I was trying to get support on some other language, and I was like, if it was Python, I was missing Python. It was Python. I know I would find out I'm looking for in about 5 articles. So that's it. So just ask your questions in the chat so that we can see it together. So even if you have millions of rows, if you have millions of rows, that's the point. This is a simple use case. In the real life, I have millions of rows. Yes. I mean, imagine a data set that contains all information about maybe all the citizens, all the COVID-19 cases. That will run into quite hundreds of thousands of rows, right? So it's the same thing. Really, it's just the same procedure. Now you might have to think ahead because you don't have all the time or you don't have all the compute. I mean, we have powerful laptops to do that. And then that's where, like I said, sometimes some of us are using our phones. I'm guessing for the hackathon, the data set won't be that large, but it might be a bit slow on your phone. Definitely be faster than a laptop. And also there are other faster laptops. So basically it's the same thing. It's the same thing you're going to do, but you might just have to optimize your code because you now have a larger data set to save your compute time and cost. Because in real life, most times computation is going to take a lot of, I would say, resources in terms of cash and time. So you want to make sure that your models are training as fast as possible and as accurately as possible. So having trained all the 5 models, we can see that the best model that can actually predict the amount of tips for a given pattern measurement to be the lowest RMSE, and that is what support vector machine. So it's how low. So I think I said higher before. So that was an error. So it's how low because it's an error, right? It's how low the RMS is looking for a very, very low RMS. The lower it is, the more accurate your model is, because that is how much it deviates from the actual the actual value that is. Okay. So I'll take questions for a bit. I'd like us to actually think of our questions. So we shown how to import models, right? So let's see what if we use some other closer it is to 0? Yes, exactly. That's the question. Closer it is to 0. So K nearest because we look at on this, right? Okay, so I think I should leave this up so that we can actually try it. So we look at let's see, this is where you're doing your import, right? I'm not quite sure I understand your question. Yes, everything looks different in Python because we are doing Python. Okay, so they are different. So this is machine. I mean, please confirm you're in the right class. Okay, or this is machine learning with Python. I'm maybe guessing you're talking about the 50 days computer camp learning, and that is another program that teaches different approaches. So there are, like we mentioned, I think we've covered this earlier in sessions that there are different tools to perform the same task. We are using Python because we established that Python is simple, intuitive, it has a lot of resources that learners can learn with. So Python is usually very good because you will learn a programming language, you will also learn a bit of data science, machine learning, enough to get you started, and now let's move forward and upskill. So as always, yeah, it's an introduction class. So we expect that you go to the learning resources we provided and the hackathon to push your learning. That's the whole idea, really. So learning other languages once you know a programming language is usually easier. It's usually easier. I mean, it's easier. You can, because you understand how languages work, you can pick a syntax, pick a code block and work with it. You can, I would say it's easier. For example, I know I have written codes in other languages that did what I wanted it to do, but I don't understand the code, right? So it's easier. I would say it's easier. All right, so let's try to do this. Use import these other classifiers. Okay, yeah. import these other regressors, and let's see what you'll get. I'll leave us for about 5-10 minutes to do that. So you can just go over the video again. I'll take a screenshot of what the importing phase looks like. All you have to do is import and then call your model. This is your imports right here. So I'm fine with this three has the lowest RMSE. So just go over what we've done already and try that with these other different models. And when we come back, we're going to review. It's going to just be question and answer. Yeah, the resources cover exploratory data analysis as well. Please, I'm really begging us to. The link to the data set is already in the info pack. So please, I'm begging us to go over the resources provided in the info pack, right? The AI innovation resource in the info pack. And the last page, A5 of that info pack, contains other text and web resources for you to get started. All right, so we'll go on that break 10 minutes. And when we come back, we'll look at the Kaggle hackathon that we'll be doing. We'll just show us how it's going to go, how it's going to run, how we expected to go about it. So the notebook is not going to change because still it's a development. So that's why we already shared you the learning resources, right? So that you can also, I would actually prefer that, we don't share it. So you are forced to type it out. Let's not get too much copy and paste. I type it out a bit so that you can not commit things to memory, but that you're actually doing it, right? So let's try that. Okay, so please go over the videos, and then but what we'll do is you will find text resources and notebook resources in the not in the info pack now, in the text resource that is in the info pack. Let me show what I mean. Right here. So click here for introduction to Python resource, Python and ML resource. If you click here, you see the AI innovation, Python and machine learning resource that I mentioned earlier. Here you will find I know a good number of us have actually come to it already. I mean, some of part of AI innovation, right? So this is 132 pages of just machine learning. This will cover, you will find, because I know some people might not even have gone through it at all, but you will find, see, digital notebook, how to get started with solution, all your what now, different things that we didn't cover, we might not have covered in detail in this class, right? You will find them on this notebook, on this material content, even the same tips data sets, right? Okay. So what is the difference between a regressor and a classifier? It's simple. Regressor is for a continuous variable. Classifier is for a discrete variables. Regressor is for what do I call it? Regressor is for a continuous variable. Classifier is for classification tasks. Right? We cover this in types of machine learning algorithms. Classification, regression, and all those things. So classification, you use a classifier because you have discrete variables. Regressor, you use your regressor because you have continuous variables. So you will find here what I mentioned earlier. I mentioned about I want to show us the bit of the theory of linear regression. So it's here. So please, really cool if we read up on it. Now, we know it's yes. So you find about the mathematical concept of linear regression here. For people that are interested, how the line of best fits, right? You have equations here. I'm sure mathematics will be very excited. So please, you can look through this and for more understanding. So basically, everything is here, and I would like to call it the goodie bag or the gift pack, or how do you call it now? Is really the last page or last two pages. yeah, some of these data sets might not be available. True. What I will do is I will include on the info pack a link that has all the data sets, all the data sets, all the data sets. So that will be there in the info pack right after this class. Okay, so you will be able to get that. All right. So we're supposed to be doing an exercise. When I come back, I'll talk about this page and the resources and the hackathon. All right, so I'll leave us to it. Let's do some imports. Let's see which one works, which one doesn't work. All right. I hope we are making progress. We're following. I hope we are attempting this. So just drop in the comments how it's going. We have 3 more minutes. Let's just see have we been able to which one of the key nearest neighbors reach regression and those with the lowest RMS. So let's get into it. I'm not going to cover, and we're not going to go into all of them in detail again since the principle has already been laid out here. All you need to do is import, check out your um, decision tree, whatever it is really, and then fit on your X string and your Y string. That's really is that simple. It really is that simple. Right. So I'm going to give us a few minutes now. You have other questions. You have other questions you want to ask. Please go ahead and ask them now. So we have a few minutes to put all that together. Ask questions. Please ask questions. All right, I was thinking it was a few minutes. All right, so I'll take your questions now. Thank you so much. I feel that we've all just your question. So what's the command for installing pandas profiling? We discussed that earlier. I think it's still here actually. Pip install pandas profiling. I think you might have some, I'm not sure now, but there might be maybe another way to install it. If this doesn't work, just a small process to solve it. Is it possible for a data set to contain more than one label? Yes, it's possible. And it should contain more than one label. In that, yeah, the WhatsApp group is still going to function after the completion. Yes. Okay, so Said, I will answer your questions after this. So the data set can contain more than one label. I mean, if it's a classification, if it's a binary classification that there are two classes, yes or no. Does this person have cancer or not? Does this person have to be in the hospital or not? Yes or no? That's two classes. Class one, class class one. This is the command. This is it. If install pandas profiling, you put your exclamation, put install pandas profiling. So more than one label, yes. Where is it? Yeah. So yes or no, that's two labels. Also, you can have multi-label. So if the class is yes, no, or maybe. If the, for example, last week I had to build. I was doing something around NLP, and I was trying to classify types of questions. Now there are the WH questions, the how questions. There are about basically there are about 4 classes, right? So that's 4 classes. So you can have multi-label data sets with different kind of classes. You can have binary classes, and you can have a regression that has almost infinite number of classes because it can fall anywhere, right? Because regression does not have a definite bound. Okay, so a definite class bound. All right, so yeah, someone's asking about the purpose of DSN EFS membership ID. So the DSN EFS membership ID is your unique membership number. That is your unique membership identity that you need to access opportunities from Data Science Nigeria. As we covered in the beginning of this class is just one opportunity, one avenue from Data Science Nigeria. There's a DSN AI bootcamp, biggest AI bootcamp that everybody wants to attend, right? Where you get opportunities for scholarships, for job opportunities, research, so many other wonderful things, and other initiatives from Data Science Nigeria, course grants, data grants, everything we do here. You need that membership ID to access them. And also, because we rate our members, we score our members, very soon we will have a membership leaderboard. We need that also to also benefit, because this is the largest pool of data science talent in Africa, in Nigeria, and even across the world. We have some of the top African talents right here, Data Science Nigeria. So we have partners and people that need those talents, and to get our top talents, we must be able to say that, okay, these are the people. Look at the Kaggle hackathon you did. Look at the projects you're able to do. So that's why you need a membership ID. It's really important. Okay. So what do you stand to get from being a DSN member? Check out the website where you sign up for the DSN membership. Yeah, we have all the benefits and all that. All right, so I think that's all the questions. All right, so let's check out our so if you have the info pack, if you reload the info pack now, you see that all the data sets have been uploaded. Today's data set is here. Yes, there's a time limit to complete the Kaggle competition, exactly 7 days, right? But all you have to do is make a submission. But we actually looking for the top people. But you would also, everyone, you must look at the submission, and you must submit your details, right? How you do that will be communicated after this class. Basically, you just submit your details on a form. All right, so let's check it out. Then you will find here Kaggle hackathon. So the link to the Kaggle hackathon has been uploaded on the info pack for everybody to join. And all you have to do is click here, right? Get to Kaggle. You have to use the link. So you have to sign in. I'm not signed in here. So let me, how do I do this? Okay, you know what? Let me switch. I need to switch so I can join this competition. All right, so if you have the info pack, please navigate to the Kaggle hackathon and open it, while I also sign in here. Yeah, the info pack will be available after this program. Yeah, we discussed that already. All right, so you must see this, and you see 7 days to go because we have 7 days to complete this hackathon. This is the problem statement, and I won't tell you what it is, but you can already see there are questions in how to spend the night. You can already tell what kind of problem it is. Okay, you can already tell what kind of problem it is. So all you have to do, I hope my screen is visible now. Is my screen visible for people following online? Someone says my screen is invisible. Okay, yes, thank you, everyone. Thank you. All right. So this is the overview. How will you be evaluated? We evaluated F1 score. That already tells you, you can already know that this, what kind of problem this is. I want to say also, it's really simple, right? It's very, so this is data. So you download the data set, you have to join the competition, right? Let me minimize this chart. So you see join competition up here, all these things are. Okay, so join competition, click here and you join. Once you join, you can in the discussions and the leaderboard, you can see your team name will show up here, your notebook, team members. So it's an individual competition because it's individual certificates that we are awarded, right? So we expect that everyone is going to do this by themselves, right? We don't want anybody doing this for anybody, please. So yeah, all right. So that's it really, and that's about it. You download your data set, right? You do everything we've taught you, your predictions. See, so let me see how many. Let's just look at it. Let's look at the train set. The train set is just 200 kilobytes. So just 3,000 rows, right? 3,000 rows, and the distributions look okay actually. These are right. This is cool. They're all numbers really. This is a very wonderful data set for you. So you might not have so much of pre-processing to do. You will have to pre-process, but not too much. And the data cleaning shouldn't be that much as well. Someone is asking a question. I can go through after signing in. Yeah, so you need to sign in. You need to join Kaggle. This was covered in the last class, I believe. This was already covered in the last class, right? Right? Kaggle, I know it was covered. So how to, just sign up. Kaggle, just go to Kaggle, you sign up as get a Kaggle. Yeah, so all you need to do, please check out the video for the last session. Right? So all you need to do is go to the info bar, click here to join. If you've already had your Kaggle ID, you should open up. If you don't, you need to sign with your Google account or whatever account you sign up for Kaggle. So just check out the last class video so we don't. Oh, okay. So what was I going to talk about? Yeah, sample submission and all. Now, so what we're going to just do is, like I mentioned, what we do, because here at this center we are very big on creating content and just leaving it for people to be able to access at any time. If you check out the content we mentioned here in version 2021, you will find out that there is the last page, the 5. You will find this, and this is just. Please ask your question. Please someone raising the hand. Please ask your question in the chat. Who determines the leaderboard? So the leaderboard is automatic, right? It's determined by how good your model is. Kaggle, it's automated on Kaggle. Once you make your submission is scored, right? It will be scored, and if somebody's submission is better than yours, the person will, be ahead you on the leaderboard. It's that simple. And you will see here already stated how you're scoring, how you will score. Evaluation, F1 score. F1 score talks about the ratio of true positives to true negatives. I've already told you what kind of problem this is already sharing that. You already know what we're doing, right? So F1 score will be used. All right. So please sign up, sign up, sign up. All right. So lastly, where are we? I'll show you. Yes, here. So what we have here is a collection of content. There is a video actually by your machine learning tutor, who taught you last few classes, Opeyemi, on how to make your model from scratch and how to submit. You can download that video via this link or watch it on YouTube via this link. So all resources, yeah, you can make multiple submissions. The goal is to make multiple submissions. Submit until you are number one. Keep improving your model until you are number one on the leaderboard. And this is I see test and train as everything. I don't know. Yeah, okay. So if you watch the video, you will understand. So the test and train, you will see here that they are separate, right? So this train is your normal data set that we've been using, that you will split into train and test. Then when you are done, you are going to use the model you have trained. This one you will still split this train into train and test, or as suits you, right? Then you will now, when we learn our predictions, we predicted on, where is it? We said is random forest model. Sorry, said random forest model does predict X test. So this that you will predict to generate your submission is, where is it? Is this test. So this test is for after you've trained your model, you've built your model, you've evaluated your model, you now want to make your submission on Kaggle. You will predict on this test set. Okay, I hope that's clear. All right, so any other question? So back to this. So you will find here on YouTube a guide, end-to-end guide on how to start your model, do your EDA, more than we even covered in this class. Let me just open it up. And you can also download it via this link if you want to just download it. Now you want to know more, you want your own EDA to be better. We've created resources by, yes, stratified shuffle scale. That's what I'm going to remember that. So we've created resources and articles by other AI Plus members and people that okay, Abdul is asking that, can your submission contain multiple models and the system will take the best model? No, you can submit multiple times and the best will be selected, but you can't even submit multiple things in one model. You can take a look at the submission file. Submission file will only contain your predictions. So can you run through on how to submit on Kaggle? That is exactly what this is. This is how to submit on Kaggle. So these videos are how to submit on Kaggle. So how do you access these resources? They are on the info pack, like I mentioned earlier. They've always been on info pack since day one. This is it. This is the resource. Click here for Python for an ML resource. Okay, and I have linked it up right here. So if you click here, I'll take you back here. Okay, so back to what we're talking about. So you find out there's an article also how to enter your first Kaggle competition. If you like text and you want to read up more, read this. It will tell you everything that is already in the video. More on EDA, data processing, how to improve accuracy, how to develop a model from scratch, different models you can use. And I'll tell you this, that this last three can help you jump up the leaderboard. So you want to read through all this. Really, these are really resources for you. You want to read through all of them, right? And combine them to get the best result. Okay. Then this is most important, and it's something we take really seriously here at Data Science Nigeria. And I'll read it out word for word because that's what it is. Integrity is a core value at Data Science Nigeria, and as such, we expect all participants to maintain honesty throughout the period of this competition. Submission files, notebooks, and code solutions should not be exchanged among participants. Multiple accounts and other dishonest acts are extremely frowned upon and would immediately lead to the forfeit of certification rights. That means if for any reason it's discovered that you were dishonest in any about the competition, there's no certification, there's no second chance. So please, really, it's just learning, it's for our learning. Let's do it. Let's read up. If you don't know anything, go to Google, read up some resources, then come back to class and say, guys, I just learned this. Let's try this and see how our models can improve. Hey guys, I just learned this. How can we use this? I just discovered another model that can even do better than random forest, that can do better than XG boost, that can do better than cat boost. Right? So that's what we want. We want to see you push your learning. We want to see you take this and really do amazing things. And that's the idea of this hackathon. It's a learning hackathon to catalyze your learning. It's going to really help you learn a lot within a short time if you give your time to. So we have 7 days, and in 7 days, so nobody, let me also make clear that because nobody is going to close this hackathon. You see, it's automated by itself. It says here, it's 7 days. Where is it? Where is it? 7 days to go. It's just that's just so in 7 days it's going to close. By tomorrow, even by today, you see the link to how you are going to submit, right? And I think there'll be some people that will receive some emails because I saw some people had duplicate of multiple student IDs. So that will be resolved. How you're going to submit, that's also going to be resolved. It's really important. You're going to submit your for the specialization. Okay, so this is not the channel for the 50 days postcard. I'll answer your question. You have access to the videos and do the assignments after 50. Yes, yes. You have access to all. So, any other questions before we close? So this is the video I mentioned earlier. So this will show you how to download the data sets. Right? This will show you how to everything you need to do, basic EDA. You see, it will also show you how you will export your data set. You see how to get a submission file and you submit on Kaggle. Yes, that's what I just said. The Kaggle commission will be done in exactly 7 days' time. Yes, that's what I just said. No, it's not like it to be done in 7 days' time. It ends. He said he wants to refresh small. So, okay, so it's, I mean, we built a model in class in less than an hour, right? So you have all the next 7 days. You don't have to build the best or the biggest model in the world. You just want to see that you are able to take what you have learned and build a model and do that solution. That's all. Of course, I mean, we want to also see people that can do the best model. So that's it. That's it. The competition has started already. I can't unstart it. Sorry, don't worry. It just started a few minutes ago. Actually, it started by 11. Yes, 1, 2 days of the class. Okay. Any other question? Any other question? The Zoom registration still shows. Yeah. So no, today is going to be the last session. So don't worry about the last the Zoom registration session. So last next Tuesday. So today is the last class of 12 class. 6 weeks, 12 sessions. Yeah, so this is the last class. Any other question? Yes. So as you can we access our attendance as yes, just go to the info pack and check out the attendance by maybe by tomorrow. Please refresh. I opened the Kaggle link from the info pack, so it's there. Can we get step by step option info pack? Please, that's why it's really important to. It's on Joseph Adeniyi. It's right here on the info pack. This is the step by step. The video I showed everything. All this is on the info pack here, right? Okay, so Kaggle link is on everything. So I think also how to know how I perform what's attendance. Yeah, so I will that was going to answer that. You will see the list of attendance for days you attended and the days you didn't. That will be released before next week by before Monday. You see that on the info pack. Yeah, all that will be on the info pack, all those details. All right. So any other question? So I have about I'll give about 3 minutes for No questions. All right. Okay, so thank you all for your passionate journey over the last 6 weeks. It's been amazing. And the reason we are doing all this is because, as we stated at the beginning, there will be certificates, and the criteria for certification have been defined on the info pack since day one. So all you need to do is check out the info pack. All right. Let's see. And the question, can you be good? Yeah, so the quiz assessments, I should state, the quiz assessments are open till the Kaggle competition closes. Once the Kaggle competition closes, the quiz assessments, all of them will close. That means the next 7 days, you can't do any quiz if you've not done it before. Right. Yeah. Okay. All right. All right. All right. Yeah. We love you guys. We love you all so much. We love you too. Thank you so much for learning with us. And please, more than this, you can go on and join the 50 days pre-boot camp class. And you also continue your learning day after this program. There's still about 30 days of learning left. Oh, yeah, sure. You get the feedback form. You are going to get the feedback form. Yes. All right. You are very welcome. Okay, so we'll end class there today. I will continue our communications on the business, the group chats. All right, we have heard of this. All right, okay, beautiful, beautiful. Thank you, everyone. Enjoy the rest of your day.